Okay, so let's start to the class. Today we are going to discuss losses and efficiency of three-phase induction motor. Okay. In the last class, we already discussed that rotor EMF, rotor current, and power input to the rotor. Okay. As well as we already find out the torque equation and shaft power and shaft torque. Okay, so shaft power we already find out in the previous class, and shaft torque, output torque, or you may be called as a shaft torque. Okay, that is nothing but power by rotor speed. So today we are going to discuss about the what are the losses take place in the three-phase induction motor and how we can find out the efficiency of the three-phase induction motor. Is it not? So just first of all share the screen and then we will continue our discussion. Okay, so losses and efficiency of three-phase induction motor. Losses and efficiency 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 of three-phase induction motor. Three-phase induction motor. So first of all, if we are able to find out the what are the various type of losses take place in the in the three-phase induction motor, then we are able to find out efficiency of three-phase induction motor. As we know that efficiency of electrical machine, whatever either maybe transformer or induction motor or other types of rotating machine, that means output power divided by total input power. Okay, so if you have any one of the data, that means either output you have or input you have, then you are able to find out efficiency. So if you have input power of three-phase induction motor and are we able to find out what are the various losses take place in the three-phase induction motor, then just you simply subtract the losses from the input power, so you are able to get the value of output power. Okay, so we can find out the efficiency of the three-phase induction motor. So first of all, we try to discuss what are the losses, various type of losses take place in the three-phase induction motor. Is it not? So the losses in a three-phase induction motor take place maybe classified as the fixed losses and variable losses. Okay, fixed losses also consist of various type of losses. We just elaborate one by one, as well as the variable losses also consist of various type of losses. So that will also be elaborate one by one. So first we try to discuss about the what are the fixed losses in the three-phase induction motor, which losses we can call that fixed. Okay, so the losses in a three-phase induction motor, in a three-phase induction motor are one may be classified as fixed losses, another as a variable losses. Okay, so you can say that one is your fixed losses, fixed losses, Another is your variable losses. Okay. Variable losses. So just we try to discuss which one we can call the fixed losses. So just elaborate the first of all fixed losses. Fixed losses. These losses are composed of, that means these losses are consist of core losses, bearing friction losses, brush friction losses in on rotor induction motor only, and winding losses. These losses are constant for a induction motor. That's why it is known as the fixed losses. Okay. So just to elaborate this one, these losses, sorry, this these losses consist of core losses. First of all, core losses, core losses. Another is your bearing friction losses, bearing friction losses. See, brush friction losses in on rotor induction motor only. Brush friction loss, brush friction loss in on rotor induction motor, in on rotor induction motor only. You maybe write in short terms, that means on rotor induction motor only. Okay. One is your on rotor induction motor, another is your squirrel cage type. Okay. The two types of induction motor can be classified as the on the basis of construction of the rotor. Okay. So basis of construction of the rotors. Okay. And next is your winding losses. Okay. So winding losses. So these losses we can consider as a constant losses. Okay. These losses are taken to be constant, are taken to be constant over the normal working range of the induction motor, over the normal working range, over the normal working range of the induction motor, working range of the of the induction motor friction losses may vary slightly with the load and speed, but still you may be considered as a constant. Okay. So friction loss may vary. Friction loss may vary slightly with load and speed. So friction loss may vary, but may vary slightly with load and speed. Slightly with load and speed. With load and speed. But this loss is also considered constant as the speed vary only by a small amount over the normal working range of the induction motor. Okay, so but this loss is also considered constant. This loss is also considered constant. Also consider constant as the speed vary only by as the speed vary only by a small amount, only by a small amount over the normal working range of the induction motor, over the normal working range, normal working range of the motor, of the motor. Okay. So these losses, that means core losses, friction, bearing friction losses, brush friction losses, and winding losses can be taken as constant over the normal working range of the induction motor. But slightly friction losses may be changes with the load and speed. We already know that the speed is very slightly very small amount over the normal working range, so we can consider friction loss as constant. Okay, so a three-phase induction motor under its usual working condition has very low friction frequency current in the rotor circuit. Okay, so a three-phase induction motor, as we know that the rotor frequency we already drive in the previous classes, that means product of the slip into supply frequency. Okay, so that frequency is very low in the rotor part of the whatever the current flow in the rotor circuit. Okay, as a result, rotor core losses almost proportional to frequency square, that is again smaller value, so we can neglect this one. That means we can only just consider the constant value of the core loss. Okay. So ये 3-phase induction motor, ये 3-phase induction motor under its usual working condition, under its usual working condition, has very low frequency current in the rotor circuit, has very low frequency current, low frequency current in the rotor circuit, rotor circuit as a result, rotor core loss almost proportional to, as a result, rotor core losses almost proportional to frequency square are negligible. Almost proportional to frequency square are negligible. Okay. So only we can consider stator core loss. Yeah. So the fixed losses or rotational losses means the fixed losses or rotational losses or rotational losses, that is friction winding and core losses, can be obtained directly. The friction winding and core loss, winding and core loss can be obtained directly by performing no load test on the induction motor. Okay. Can be obtained by directly by performing no load test on three-phase induction motor. By performing no load test on three-phase induction motor. No load test on three-phase induction motor. Okay. So if you perform on the no load test of three-phase induction motor, only consume the power of no load losses, or you maybe say that the rotational losses or fixed losses. Okay, so that can be obtained by performing the no load test. So fixed losses equal to whatever the power input at the no load minus some losses of the I square R loss of a stator part that you have to subtract from the power input at the no load. Okay, then you will get the fixed losses. Okay, so we are able to find the value of fixed losses. So fixed losses equal to power input at no load minus stator I square R loss at no load. Whatever the ohmic losses take place in the stator winding at no load, that you may be subtract from the power input at the no load. Is it not? So you are able to get the value of fixed losses. So just to use subtract, that means power input. If you plug it in the stator part of the three-phase induction motor, power input at no load minus a stator I square R loss at no load, minus, sorry, minus a stator I square R loss, a stator I square R loss at the no load, a stator ohmic loss, ohmic loss, or you maybe say that the I square R loss, you know, or you maybe say that I square R loss at no load, you know. So I square R loss we maybe represent the stator resistance either maybe R1 or rotor resistance by the R2. So corresponding to that, we maybe put here R1 or small r or capital R1. Okay, whatever you maybe want to represent the stator winding resistance. Is not, you don't confuse about the representation of the resistance. So either you may be represent some as notation, that means R1 for one represent for the stator and R2 if you want to represent it for the rotor resistance. Okay. Here I just represent the stator resistance by the small r. That's why I have put here I square R loss. Okay. R square R loss at the no load condition. Okay. At no load condition. At no load. Okay. And next, what we have to consider, that means variable losses. Okay, so this is all about the consider constant loss. So let me write here something like this one. Okay, next is your, so this is all about the fixed losses. Okay, what are the component consist in fixed losses and how we can find out the fixed losses. Okay, if you perform the no load test on the three-phase induction motor, then whatever the input power supply taken from the supply, and just you subtract the stator ohmic losses or I square R loss, then you will be able to find the fixed losses. Is it not? fixed losses. And next we have to second part of the losses, that means variable losses. So just we try to elaborate the variable losses of three-phase induction motor. Okay, what are the, that means simply you maybe say that variable losses or consist of the ohmic losses, that means stator ohmic losses and rotor ohmic losses and some brass contact losses or steel load losses. Okay, so just try to elaborate this one, variable losses. That means next is our variable losses. Variable losses. Variable losses. These losses are consumed. So these losses are consist of stator ohmic losses, rotor ohmic losses. That means which are vary on the load current. Maybe that this ohmic losses is I square R loss. So whenever the current is changing, that means this value of losses changes. That's why it is known as the variable losses. You know. So these losses are consist of these losses are consist of stator ohmic losses. Stator ohmic loss. Stator ohmic loss. Rotor ohmic loss. Rotor ohmic loss. Press contact loss for on rotor induction motor. Press contact loss for on rotor induction motor or on rotor induction motor. That means on rotor can be represented in short term, means WRIOM on rotor induction motor only. That means this loss is not take place in the squirrel cage type induction motor. Okay, so only brush consists in on rotor induction motor. That's why we consider here the brush contact loss for the on rotor induction motor. And next is your steel load losses. Steel load losses. So steel load losses in three-phase induction motor is very small. That's why you may be neglected these losses when you consider the variable losses. Okay. In on rotor induction motor, if press contact loss is given or mentioned in the problem, then you may be consider about the uh, I think maximum it is 1% to 2% of the total power of the rating of the three-phase induction motor. Okay, If not mention on rotor induction motor in your problem, then you have not bothered about the brush contact loss. So only you maybe consider a stator ohmic loss and rotor ohmic loss as a variable losses. So when the load changes, these are losses, stator losses and rotor ohmic losses which changes. That's why it is known as the variable losses. Okay. And these two, last one is you may be considered as very small amount of losses take place as the stay load losses, so that you may be neglected as comparison of the rating power rating of the motor. Okay, and third one we already explained that if mentioned, then maximum 1 to 2% uh, of the power rating. So you may consider in your problem. Okay, otherwise you will consider only the stator and ohmic losses. So through this one, you may be also uh, directly obtained the two losses, stator or ohmic losses, by the block rotor test performed or load test, that is known as the also load test, or you may be called as the block rotor test. Okay, so you are able to find the summation of these two losses, stator ohmic losses and rotor ohmic losses, with the help of block rotor test or load test. Okay, so the stator and rotor ohmic losses can be calculated. So the stator and rotor ohmic losses and rotor ohmic losses can be calculated directly in the can be calculated directly in case AC resistance of calculated directly in case AC resistance of a stator and rotor winding are known. AC resistance. If the resistance of stator and rotor part you know, then you maybe directly calculate it. This stator ohmic loss and rotor ohmic losses. Okay. If you don't know the resistance value, then you perform the block rotor test or load test on three-phase induction motor. So resistance of stator and rotor winding are unknown, are known. So total ohmic losses can be obtained by performing the, or otherwise you may be perform the load test of three-phase induction motor. Total ohmic losses can be obtained by obtained by performing block rotor test on the induction motor. By performing block rotor test on the induction motor, on the induction motor. Induction motor. Okay, so these losses we can shown through the single line, through the line, or maybe in a structural point of view, what are the losses take place in which part of the three-phase induction motor. Okay, so you are able to more visualize what happens in the three-phase induction motor when you calculate various type of losses or output power or input power relation. Okay, so up to this point we already tried. Suppose that this we tried to explain through the uh, uh, pictorial point of view of the various losses and input power and output power relation, whatever we already mathematical tried in previous class. Okay, so just try to end various type of losses today we already discussed few minutes earlier. So this is the power input to a stator from the main supply or mains or supply. Okay, so whatever the power input taken from the supply, some part of the power loss is as the stator I square R loss, and some of stator core loss, and what are the remaining power go through the rotor part. Okay, so this one here you maybe find out rotor input power, or it is also called as air gap power. We already discussed in the previous class. Okay, so whatever the power input to the rotor from supply input means to this point, that is known as the air gap power. Okay, so these two losses take place in the stator part, and now from onward this point, whatever happened in the rotor part, we just try to mention here. Okay, so whatever the air gap power and input power, you maybe lost some power as the rotor I square R loss and rotor core loss, that is negligible. Here you may be consider okay, so rotor because the frequency is very small, and rotor core loss is square of the frequency, so that you may be negligible. And some part of power losses as the friction and winding losses we already discussed here, and winding losses. Okay, then whatever the remaining power from this point, that is power output at the shaft of three-phase induction motor. Okay, so up to this point, you may be consider rotor I square R loss and rotor core loss, that is negligible. So if you subtract the rotor I square R loss in the air gap power, that is equal to nothing but mechanical power developed in the rotor part. Okay, so and if you subtract this one, that means friction and winding losses, then you will get the output power or rotor shaft power, that is represented by P shaft. Okay, so this is the all about the losses and power relation from the input to output of three-phase induction motor. So now you can easily find out the efficiency of the induction motor from this relation. Okay, so either you have to give in input power or output power, and any relation you have to just find out and just subtract the various losses, and so you will get the proper whatever your required quantity. Okay, so this flow chart you maybe keep it in your mind, so you may be able to visualize which losses take place in which part of the three-phase induction motor, and what is the you maybe relate power from one point to another point. Okay, that means from this point to this point, how we can calculate from subtract. Suppose that if we air gap power we want to find out, and these two losses if you given, then as well as these power input to the stator point, then you will get the air gap power from subtract these two losses in power input. Okay, so this is all about of the losses and efficiency of the three-phase induction motor. So just we stop here, and in the next class we will discuss.